Hi, I'm Krithika Prakash, a senior technical staff member at the IBM Cloud and Cognitive Development Organization. I'm also a member of the Open API Foundation representing IBM. Very excited to be here at the API Specification Conference virtual experience in 2021. And today I'll be talking about declarative API management. I'll first talk about API management landscape. What is API management? What constitutes an API economy, the life cycle of an API, the various persona involved in a full-fledged API management solution. And then we'll talk about low-code or no-code tooling. How can you reduce the number of lines of code that someone has to write in order to put out an API, manage it, govern it, monetize from it, and so on and so forth. On the same lines, how can you empower a single persona to do all of these various tasks that are involved in an API management? Maybe like a full stack developer for API management. And that's where the declarative API management comes in. How can you empower a single persona with no code or low code tooling? And for that, you need to understand how you can declaratively manage APIs. So let's get started. When you think about API management, you have to focus on the API lifecycle. So just creating APIs and making it available in your website is not it, right? As many of you might be aware of, you should first be able to create APIs. So for that, you should be able to understand what things are you going to be exposing as APIs, what services, what data, what systems in the enterprise are going to end up as APIs that can be invoked by someone else, maybe a business partner or external developers or whatnot. So the first step in an API lifecycle is creating an API. Next, as soon as you identify the potential for making your resources available as APIs, immediately you want to think about security. Who can access those resources? If it is internal data, you don't want to have the whole world access the resources. So you start to think about, are my APIs going to be public APIs, private APIs? Who can access them? How does a consumer get access to these APIs? Do I have to be classifying my consumers into premium consumers and free consumers? But all these decisions have to be made upfront so that you can clearly secure your APIs. The third thing in an API lifecycle is management of APIs. Your APIs are not going to be the same throughout. There's going to be different changes in your API. Maybe you added a new parameter to the API. So you cannot request your customers to wait until you finish upgrading your APIs. So you have to think about versioning your APIs, right? So how do you version them? How do you govern them? How do you analyze which APIs are popular? Which one is getting used up a lot more than the others, so that you can plan to invest in those areas and come up with new APIs that can help you and your customers. And the last item in the API lifecycle is socialization. You have done a very good job about planning your APIs, creating them, making sure that they are secure enough. But if no one is going to use those APIs, then it's of no use. So you need to have a developer portal where you can socialize your APIs and invite developers to come and start using them, your business partners, so that you get the most out of what you have already invested. So as you can see from the API lifecycle, there are various tasks involved, and each of those will need different kind of skills as to API development, securing your APIs, managing and monetizing them, socializing them, designing your API flows. So there are a number of things involved. So a very good API strategy would extend across all teams in an organization. So here I'm going to show you some of the typical roles involved in an API management. So the API developer builds the APIs. He or she would have to know enough details about what information that is being exposed as APIs, but she shouldn't have to be trained about all the internal systems, the databases, the services, how they interact with each other. So without having to have her trained in all of these internal systems, An API developer should be able to know enough to be able to expose the right parameters of the API, what input request can be received, and what can be returned back. The next is the API product manager. So the product manager focuses on the overall strategy of where a company has to invest in API management, like which data, which part of your services you will have to make as products. So basically building a catalog of APIs, publish APIs into catalogs, apply rate limiting to the APIs, how is it shared in the internet? All that is led by a product manager. So these two, the API developer and the API product manager, you can call them to be part of the API providers. Now comes the API consumer. Whoever is going to be consuming the API should be able to easily discover APIs and be able to reuse them. They should be able to use the APIs in newer business projects so that they get the maximum benefit out of consuming your APIs. Next is a DevOps person. One of the main things about today's technology and the advancement is how do you make sure your APIs or the servers running them are up and running throughout? So the DevOps person is able to take the services, the APIs, and be able to manage them, make it highly available using Kubernetes controls. So this is the container orchestration framework I was talking about. So the DevOps person manages the whole infrastructure as to where your APIs are running. There's also the role of an IT architect who has to ensure that the solutions, they align with the corporate IT and security objectives. So while you're in the process of building services, identifying which parts can be APIs, and making an API management solution, should always keep in mind about the low code or the no code tooling that you can introduce in the organization. IBM has got products like App Connect and API Connect, which will let you do that. But the core technology here is that as an API developer, I should be able to drag and drop things to create a business flow, to be able to connect to systems which are internal within an organization but are going to be exposed as APIs. This kind of no-code tooling will increase the productivity, increase the return on investment, and also will reduce the time to market. You should ensure that your platform is highly scalable, the security and everything is baked into the platform itself. So in the sample picture that you see here on the right, App Connect, IBM's App Connect has a flow builder where you can use connectors to connect to one of the systems. And then based on the response from that system, you can build a flow as to how the subsequent connections to the system can happen. So if the first system returns an error, you handle that differently. And if it is a successful case, the API developer has a full freedom to build the logic, the business logic for the API, right using the UI. The trends in digital transformation requires a single person to perform a number of these tasks that we just went over. It is needed in order to be able to iterate at a very fast pace and be able to get to the market sooner. You need to be able to maintain confidence in known behavior. And also you should be able to unleash the capabilities without having to be a subject matter expert in many of these areas. Here is an example scenario. Without getting into a lot of internal details, in the interest of time, assume that you have a number of internal systems that are talking to each other. It's part of a SaaS deployment. In this case, it's a CRM system. There are digital partners who are not trusted with the CRM credentials. So you need to be able to expose the CRM services as APIs. You should be able to apply rate limits. You should be able to analyze what kind of APIs are being invoked. And you should be able to do credential management. What kind of tokens are being used? And based on that, you should be able to give access to your internal CRM systems. Map that into what is coming in and mapping that into what should be needed in order to access the internal CRM systems. And also this team that is working on exposing the API, they need not know a whole bunch of how these entire CRM system works. They are not expected to understand all of those internal workings. And also in the future, the CRM systems can be refactored without impacting the API layer. So if you look at a typical API management solution, it would need a diversity of digital connections. So these CRM systems that we talked about earlier, how you're exposing them as APIs, not just using REST APIs, but also async APIs, GraphQL APIs. So there is a diversity of digital connections that are needed. in terms of digital bonding. So this is where I want to introduce about the declarative API management. So in this picture, what I have here is an IBM's proposal of how an automatic discovery service can be used in an API management lifecycle. Let me walk you through this picture. So here you see three clouds. This is an IBM cloud. This is an AWS, say for example, and then you have an Azure. So your APIs can reside anywhere in any of these clouds. And the API developers can create APIs like OpenAPI document, or as we saw in the previous slide, it can be GraphQL or async API or whatnot. But for each of the API, they represent that with a custom resource. So when they create an API, make it available as an OpenAPI document, they also create a custom resource. So the ADS, the API Discovery Service, in each of these clusters, so pretty much the ADS can be in any cloud, any cluster, and any namespace. It watches for new custom resources being created. And as soon as it detects that a new API has been created, it processes that custom resource and pushes it to the API management platform. From there, the API management platform has the capability to make it available in the developer portal and whatnot. So here you are empowering a single persona success. Your service developers can be your API developers, and they can automate the whole API management process by creating custom resources. The API discovery service can also be doing the versioning and management of the APIs for them. Subsequently, the API discovery services can also be expanded to act like a gateway enforcement. So it can read the contents of the CR and it can provide capabilities where it can enforce security on the APIs by managing a gateway service. So everything is now automated and can be done declaratively by just managing a CRD, a custom resource definition, and the corresponding custom resources. So in this slide, I'm showing you a sample custom resource on how that is going to look like. As you can see, the custom resource has a kind API, and the spec says that this API needs to be pushed into an API management platform. In this case, it's an API Connect. You can call it as an API catalog. In the definition of the custom resource, it talks about what kind of an API it is. In this case, it's an Open API version 2, but as you can imagine, it can be an Open API version 3, async API, or a GraphQL API for that matter. And this particular instance of a custom resource, it talks about an external reference to the API. So I want to bring your attention to this part of the CR where it shows that the ADS, the API Discovery Service, can fetch the Open API document from this location. This can also be used like an internal. So if you change this tag to an internal one, then you can embed your Open API document within the CR. But as you know, there are size constraints that you cannot put a large Open API document within the CR. This is what we are proposing here to be accepted as an industry standard. The CRD process, the custom resource definition process here that you see in the screen, is adopting a similar pattern as to what Red Hat has. But globally, if there is a lot of interest in the community, this is something that we can expand out as a specification for declarative API management. As you can see here, the CR, the custom resource, becomes the source of truth for the API. Next, I'm going to show you a demo that I recorded, which shows how an API discovery service can process a custom resource, extract information about an API, and can push to an API management platform, thus enabling service developers to create APIs declaratively. So let's go ahead and deploy this. So I have created the CR right now, and let me go and deploy this as an API in a specific namespace where I have all my APIs created, namespace. So let me see what are all the different kinds of APIs I have created. Okay, so that's the API that I have right now, and I'm going to describe to see what really happened to that API. Make this larger. So the operator acted on my API, and these are the things it did, right? It
successfully processed the creation of my API and it returned a success state. So what it actually did was it pulled the Swagger from that external endpoint. And once the Swagger was received, it validated the Swagger, made sure that it is of the correct Open API format, and it also replaced all the parameters that were specified in the CR. And when all that is done, my operator pushed that API to the API manager so that it will automatically be available on the API manager. So if you were to look at the API manager UI, let me do a refresh. You would see that the API that I just pushed is available here. And you would see that there is all the operations. Basically, that API document is showing up in the API management. Here, I'm not directly using the API management. I'm using a reduced version of that to just demo for the sake of demonstration. But you can get the full life cycle, like the API management life cycle, be implemented by having these APIs declared using declarative deployment of these APIs in CR. So let me go ahead and rename this to something else so that I can show you how I can create a new API so that you can see that there'll be like 2 APIs coming in. So now I can demo one. So now this is created and I can do a describe of the demo one service, which is pretty much the same. I just changed the name, and this is happening live. It is not something that I created earlier. So you can see that now there'll be 2 APIs. So I didn't have to touch anything. All I had to do as a developer was to just create the API. And if I have to delete it, I go ahead and delete my CR here, which will automatically be taken care of, and that it will no longer be available in my API management interface. So if I refresh, the other one is gone right now. So how is this possible is if you go back to the OpenShift and look at the installed operators, I have installed this API discovery service. It's called API catalog, but internally what it does is it discovers new APIs, basically new CRs of kind API. And everything that I showed you, I demonstrated to you, is done by this API discovery service operator that is running on my OpenShift platform. You can make this operator available to all the namespaces, or you can make it available to a specific namespace, and you can mention to this API catalog operator or the API discovery service operator which namespaces I'll have to monitor in order to pick up the CRs. So you can apply restrictions like based on which namespaces you want to watch for and which developers would need access for their APIs to be pushed declaratively, right? So you can control all that by specifying some access control list for this operator so that it can watch specific namespaces, and without anyone having to touch anything other than creating the CR, it can be propagated to API management. So I think with that, that concludes the demo.
So I want to conclude with this powerful slide, which talks about the 5 foundational requirements for service mesh. With Istio taking over, there is a need to have API discovery, get the APIs either from within the mesh or from within different namespaces over to the API management platform. So here, the first one is about the service discovery, which we have talked at length. So basically, any services that come within the mesh here that I'm circling should show up as an API in the API management platform. That's the service discovery part that we talked about, which is possible by creating custom resources and monitoring and managing them using an operator framework. Next is the policy enforcement. The API product manager should be able to set policies for any of the services coming up within the mesh. So he should be able to set mesh-wide security policies, rate limiting plans, and some of the key requirements on policy enforcement. Again, this can also be done by expanding or extending the custom resource definition to include gateway enforcement policies. So that way, the API discovery service is not only able to push the APIs onto the API management platform, but also translate these policies into gateway enforcement and gateway policies, which allow the APIs through into the enterprise system through these API gateway service. And the third aspect is the secure socialization way. So how once the APIs land here into the API management platform, how would you socialize that into developer portals? So the developers should be able to auto-discover these APIs, credential management for the developers, and so on and so forth. Another key concept here is the number 4 item, which is extending the service mesh capabilities. Not just creating CRs to automate, to declaratively deploy the API management capabilities, but also to be able to extend it using WebAssembly support. You can bring in WebAssembly plugins, which can be hooked into the gateway to plug in enterprise capabilities into the mesh. So think of this as a way of extending again the CR, the custom resource capabilities, to also specify a WebAssembly. And finally, the analytics. You need to be able to get an overall view of what's going on in the service mesh. So analytics also plays a key role. To conclude, an API management platform should be able to work with traditional services, expose them as APIs, and also be able to work in a service mesh environment, which are the newer upcoming trends and technologies available to secure your cluster into mesh, into service mesh, apply policies that are service mesh oriented, and be able to securely expose them as APIs through a gateway platform, and also socialize them to external developers. With declarative deployment of API management, we should be able to make the lives of each of the persona that I talked about earlier at the beginning of this presentation much easier, so that they don't have to worry about who does what, but they just go and create custom resources, and all aspects of API management can be implemented using declarative technologies. I'd like to take up any questions, thoughts, and comments. And I'm also interested in working with anyone who'd like to take this up and make it as an industry standard or a specification. Thanks for watching, and have a very good rest of the conference.